In this video, we're doing another example of reducing fractions to their lowest terms using cancellation. And we have a couple more complicated fractions here. This first example is 4 times the quantity a minus 3 all over 4. And what we want to do is simplify this fraction by finding something to cancel. Well, because this 4 is multiplied by the quantity a minus 3 here, you can think of this whole quantity as just something. Even think of it as x, right? And if this quantity were just x, you would have 4x over 4. You'd have 4x over 4. And we know that when we have 4x over 4, we can just bring the x outside of it. This is the same thing as 4 over 4 multiplied by x. And we know from working with fractions that any non-zero number divided by itself is equal to 1. So we know that 4 over 4 is equal to 1. Because we get these two things to cancel, we divide both of these by 4 and we get 1 over 1. We just get 1 here. So this is 1 times x, or just x. So in other words, we're just left with this part that we pulled out here, this factor that we pulled out. Well, the same thing is going to be true up here. We have 4 times the quantity a minus 3 all divided by 4. We can pull these 4's out and say 4 over 4 times quantity a minus 3. And we know that 4 over 4 is 1, so we get 1 times a minus 3. And of course, 1 times anything, 1 is the identity number for multiplication. It doesn't change the identity, so we're really just left with quantity a minus 3, or we can take away the parentheses and just say a minus 3. Now, we went through all that math to make it clear, but really what we need to know is just that we can cancel the 4 from the numerator and denominator here. Because these two things are multiplied together in the numerator, 4 times the quantity a minus 3, and there's multiplication here, we can go ahead and cancel these 4's. In order to cancel something from a fraction like this, you have to have that value you're looking to cancel multiplied by every term in the fraction. And in this case, in the numerator, that 4 is multiplied by every term. We could even write this fraction here. If we distributed this 4, used the distributive property, we could say 4 times the quantity a minus 3 is the same as 4 times a, so we would get 4 times a, minus, we'd keep this minus sign here, 4 times 3, or 12. And then we'd have that same thing over 4. So this fraction here is the same as this fraction. We just have multiplied out the numerator. Then what we want to do is divide every term by 4. So 4a divided by 4 is just a. We keep our minus sign. 12 divided by 4 is 3. And then in our denominator, 4 divided by 4 is 1. So we just end up with a minus 3 all over 1. But of course, dividing by 1 is redundant, so we can just go ahead and say a minus 3. So there's a couple different ways to get to the same answer, but we're trying to get an understanding here of what we can cancel from some more complicated fractions like these ones. What about this example here, 3p plus 3 all divided by 3? Well, that looks a lot like this fraction here. We could just go through and divide each term by 3. So we'd have 3p over 3 plus 3 over 3 when we divide that term by 3, all divided by 3 over 3. And then we'd work on each term individually. So we would know that this 3 would cancel with this 3, leaving us with just p. We'd have 3 divided by 3 is 1, so we'd get plus 1. And we'd have 3 over 3 here, which we know is 1. P plus 1 all divided by 1, that 1 is redundant, so we would get p plus 1. Or we could do it this way, where we factor out a 3. So in the numerator here, we have 3p plus 3. Let's go ahead and factor out a 3. Well, when we factor out a 3 from 3p, we're just left with p. When we pull a 3 out of 3 here, we're just left with 1, so we get 3 times quantity p plus 1 in the numerator. And this makes sense because if we multiply it back out, we get 3 times p, or 3p, and 3 times 1, or 3. So this is 3 times quantity p plus 1, all divided by 3. And now this looks like our first example, where we had the 4's pulled out in the numerator and denominator. We know that we can just cancel the 3 with the 3, and we're left here with p plus 1. Again, a couple different ways mathematically to do exactly the same thing. We're really doing the same process, we're just writing it different ways. Now what about this example here? We have 9x minus 9x squared all divided by 3x. Well, let's do some factoring here. In the numerator, we know that we can pull out a 9x, right? We're looking for the greatest common factor between 9x and 9x squared. Well, we know we can pull out the 9 because that's common to both terms. We know we can pull out 1x because that's also common to both terms. We can't pull out an x squared because we're limited by the fact that we only have one factor of x right here. So we pull out a 9x, and then what do we have to multiply by 9x to get 9x? Well, of course, that's just 1. What do we have to multiply by 9x to get 9x squared? Well, that's just an x, so we get 1 minus x. We keep that negative sign in the middle. So 9x times quantity 1 minus x, and then in the denominator, we have 3x here. Just like in our first example here, where we pulled out the quantity a minus 3, and we put this 4 over 4 fraction in front, here we can pull out the quantity 1 minus x. This is the same thing here as 9x over 3x times 1 minus x, like this, which is also the same as writing 9 over 3 times x over x times 1 minus x, quantity 1 minus x. Now we can look at these individually and we can say 9 minus 3 is 3. We can say x over x is 1. In other words, the x's here cancel. And we can say we have times 1 minus x. So we end up with 3 times quantity 1 minus x, which makes sense because we could have just canceled the x's here and said that 9 over 3 is equal to 3, and we would have had 3 times quantity 1 minus x. We could have also done it at this step. We could have said the x's cancel, and 9 divided by 3 is 3, so we get 3 times quantity 1 minus x. Either way, the math is the same. Again, it's just different ways of writing the same thing. So you could say that your final answer then is 3 times quantity 1 minus x. If you wanted to, you could distribute this 3 and say that the final answer is 3 minus 3x. But that's how you use cancellation to reduce some more complicated fractions to their lowest terms.